Let me see. There should be quite a few open. Okay, if you want to sit in the back, you can sit in 3. If you want to sit up front, you could sit at 29. 3 or 29 would be the best.
Hey, Mr. Thompson.
Hey,
Lana says hi.
I just saw her.
Yes.
Are you friends with her?
She's my bestie, actually. Except Henry.
Really?
He's showing her for me. You know what I mean?
Is that her boyfriend?
Yes. Most definitely.
Oh, she's still
No,
dating
they're
him?
just friends. No, I'm lying to you. They're dating.
They're still dating?
What do you mean still?
Wasn't you dating him last year?
Oh, yeah. They had their 1-year anniversary. 2 months ago.
It's cold. Well, I thought they might have broken up.
No. What makes you think that?
I don't know. You've been talking to some boy in class.
I had lunch with them earlier.
What do you mean it's not true? It's not.
I understand. I understand the need.
Good job.
I think it should be okay. Wait, let me see if I got
Camden's.
Yeah. 2B. Oh, is that the long division one?
Yes, it is.
Oh, yeah. It's because it's changed.
Olivia.
That doesn't, so there's no 4. There's no 4? You're just changing.
Oh, that's a negative, so it's just positive.
Mindy, your answer should be fine though.
Leo. Leo's here. Ben.
So just natural art, I mean, not natural
Yeah.
Ben Camden. Okay, I actually need y'all to get out 2 assignments today. I'm not sure if we did this one, but on assignment 4, I need to make sure that you did number 2B right. I made a mistake on that one in my first period class, so there's a good chance we did that here too. So go ahead and get out assignment 4 and 5 from your binder. We're going to make sure 2B is correct on there, if I forgot to fix it for you last time. We're going to do question 6 from assignment 5. That is one that needed a different step, and I told you we'd talk about it today. Then we are going to look at the next piece of BC, which is integration by parts. So we're going to do a few of those today so you know what it's like. We're not going to go super in depth there, but you should get the general idea of what we're doing from handout 6. And then I'm asking you to practice some more of the partial fractions we did last class on assignment 7. Assignment 7 should be the only one that you have any homework, if any at all. Okay, so 4B, we might have fixed this one already, I just can't remember. Assignment 4, question 2B, sorry. This one. Did we do this one on assignment 4? Yes, okay. Was the answer inverse tangent of something?
Yeah.
We got that?
Yeah.
Okay, good. We already did that then. My other class hadn't. So we can check that. Okay, slide over to assignment 5. So I did not know the answer to this last class, and I should have. But go to question 6, please. Question 6 on assignment 5. Okay, so this was one of those partial fraction questions. So I'm going to go over this one with you, partly because so I can talk about the other piece I should have said last time that I didn't think about to say. And then also as a just kind of a quick little refresher, quick little reteach, since this partial fractions is what you're doing on assignment 7 at near the end of class today. Okay, so when you guys tried question 6, if you did the partial fractions part correctly, the last part of your answer should be correct, but the first 2 parts would be missing. And we have to do something special on this question. And so what is that? We have to do long division first. Now, I couldn't have told you on Friday why we had to do long division. And then of course I was going to figure it out this weekend so that we get it all sorted out and correct. And if I had paid attention, it says it right here. So I just kind of glossed over this too quickly. You can do you can do this partial fraction stuff if the degree of the numerator is smaller than the degree of the denominator. So you need to highlight that. When this is not the case, you have to start with long division to make it be the case. Okay? If the degree of the numerator is not smaller than the degree of the denominator, you have to do long division first. Okay, so question 6. Again, if you think you got this right, just follow along and make sure that you got the same thing that I did. But since the degree of the numerator is not smaller than the degree of the denominator, again, we have to start off with long division. So divide this into this. So we would get an x plus 2 and a remainder of 1. So after doing the long division, how does that help me with this question?
That gives the top to a
Sorry?
that gets the top to a smaller degree of the denominator.
Okay, but what happens when I divide? This divided by this simplifies to what?
X plus X plus
Good. The quotient, which is x plus 2,
X plus 1 over X squared.
good, plus the remainder over the divisor. You got to know what that's useful for. So part of my answer, and I'm going to box this in, comes from integrating x. Part of my answer comes from integrating 2. Those are the 2 things you're going to lose if you don't do long division first. You're not going to have those as part of your answer. But for the rest of this, you actually do have to do partial fractions. So factor the denominator. The denominator would factor as an x minus 4 and an x plus 2. Multiply everything by an x plus 2 and an x minus 4 so that you don't have fractions. A and b are supposed to be constants for any value of x, so we should temporarily plug in a number like what for x?
-2.
Negative 2 is a good choice because it's going to make all this go to 0. And then a step or 2 later, you figure out that b is a 6th. Okay, somebody else, what's the other number that would make sense to plug in for x?
4.
Very good. Plugging in 4 is going to make this go to 0. And a step or two later, you figure out a is 5/6. So, a being 5/6, I'll just put that here. And b being 1/6, I'll put that in place of b. Integrating this stuff is the same thing as integrating this and then integrating this. Okay, you can put the constant out front, 5/6, integrate 1 over x minus 4 as natural log absolute value of x minus 4. Over here, pull out the 1/16, and then to integrate 1 over x plus 2, it's going to be natural log absolute value of x plus 2. And then you would think all of that would be your answer, but I still need something else. Plus c. Easy to forget once you do all that work. So, second half of the question was this partial fractions that y'all practiced a handful of on this worksheet. Partial fractions I'm going to ask you to practice on today's second worksheet, so you're going to get some more practice with it. But what is unique about this question and why I wanted to start with this one, since the degree of the numerator was not less than the degree of the denominator, you have to start off with long division. This was the only question you had to do that on. But make sure we're aware of that. Okay, now what I'd like to do, before I ask you to turn in number 5, because I did ask you to try all of those, so they're hopefully if you had trouble with a few of them, you know what they are. So this is where we need to split into 2 different groups. I'll take a question or two from this assignment 5, any of them that you had trouble with, and help you out. And if you're all good with those and you checked your answers with those and you don't need to listen to me go over them because you're getting it, in the meantime, just go ahead and do a question or two from assignment 7. They're the same question types. That way, people that need to ask questions can get some more help, and those of you that don't need to ask questions can still be getting some of your work done. Okay, so assignment 5, before I ask you to turn this one in, was there any of these that you thought were harder than the others you would like me to go over with you?
Can you go over number 8?
Number 8? Sure. Okay, so until we start the next handout, which is about integration by parts, right now you've got your AB stuff plus partial fractions. But a class or two from now, you're going to know 2 or 3 more ways to integrate. So you need to start thinking about what about this lets me know that it's a partial fraction. One is, it's a big fraction that I'm trying to integrate that I can't do anything easier on. I can't take any AB shortcuts. And the denominator factors. The denominator factors, and it's a big fraction, it's probably partial fractions. So I am going to try to rewrite this into this form. Something over a plus 5 plus something over, x plus 5, and then something over x plus 1. Bless you. And the point of doing that is if we can figure out this a and this b, then these take just a second to integrate each one. So I am going to set this equal to what I want it to look like, the format that I want it to look like. Next, I want to get rid of all the fractions, so multiply everything by x plus 1 and everything by x plus 5. Temporarily plug in numbers for x to solve for a and b. So when x is -1, we get b as a fourth. And when x is -5, we get a is -1/4. Is that all looking okay?
Mm-hmm.
Is this your question, Everett?
Yeah.
Okay.
I'm good so far.
Okay. So I'm going to take A, put it up here. Take B, put it here. And now, so this little bit of an algebra, it's not really a trick, but a technique, rewrites the question to be this. So now I could say I'm going to integrate this term first. Constants you can just always pull out front. So there's a negative 1/4 natural log absolute value of x plus 5. You good with that? Okay. Over here, do this term second, pull the 1/4 out. And then what you would have to integrate is 1 over x plus 1. So natural log absolute value of x plus 1. And if we didn't have limits of integration, you'd need to throw down a plus c and you'd be done. But since we have limits from 0 to 1, we need to evaluate from 0 to 1. Okay, so plug in 1 the first time. Plug in 0 the next time, and then subtract those. So if I plug in 1, I get those two. If I plug in 0, get those two. Still okay?
Yep.
Okay, now a lot of times part of these natural log things go away. One of these 4 terms just disappears, and it's this one. Since natural log of 1 is 0, and of course adding 0 doesn't change anything, you should go ahead and switch that to reduce confusion. Okay, so if this was free response, just like in AB, you don't have to simplify any arithmetic in free responses in AB. So you can just stop there. In fact, I think you're crazy if you keep going, because if you keep going and make a mistake, then you lose the points. But to make it match up with the answer I probably shared with you, I probably condensed this stuff. So notice all of these have a 4th in them, so you could factor out a 4th. And then you don't have to switch the order of these, but I'm going to put this one last. So if you have 2 logarithms of the same type separated by addition, you can condense those two with multiplication. Carry this down. And then if you have 2 of the same type of logarithms separated by subtraction, you can condense those with division. So I would end up with an answer of 1/4 natural log of 5/3. Again, FRQ, stop the second you get to arithmetic. But practice condensing a little bit so that if you have to do it for multiple choice to see these are the same, then. I think where you've got to practice these on the other handout today, I think all the answers are condensed. By the way, if you didn't notice this, those of you that are working ahead a little bit because you didn't have questions, today's assignment number 7, those 6 questions, the answers are on the bottom of the back page. So make sure that you're checking those as you move along. Okay, does anybody have any other questions from assignment 5? It's fine if you do, but I can't read your mind. Okay, then normally when I have you guys turn stuff in, it'll be at the start of class, and I just ask you to come throw it in the basket. That way those of you that get here earlier can just do that and get them out of the way. But for now, I don't want all of you to have to get up and do that. So just make sure your name is on that assignment, and then pass it this direction, please, and I'll just take them all up at once. I'll check those, put the grade in. It's just a participation grade as well, and I'll get them back to you today. So if you need it to work on assignment 7, you'll get it back. Assignment 5 is what I'm looking for. Assignment 5 is what I'm picking up. Agenda part 5, turn in number 5. Yeah, I said this last time, and this is one of those things I'm not going to say all year long. If you forgot to do your homework, you should still give me what you have. Because if you don't give me what you have, assuming you finish it before our first major quiz, the best you can get is half credit. If you don't have it finished, you turn it in, you get half credit today, but you can get half of the points back when you finish it. So you should always turn it in, even if you forgot the homework part. You get more points in the long run that way. Anybody else have number 5? Okay. So again, part of class is I'm going to ask you to practice some more of these on assignment 7. All the answers are there. I think that you've got a good grasp of what's going on, especially based on the questions you guys asked. But we need to get quicker and more accurate and more confident and all that kind of stuff. So before I give you time to work on number 7, I also want to introduce you to the next topic. So again, we're not going to go real in depth on this, but this is the second advanced integration topic in this class. So partial fractions was number 1, and integration by parts is going to be the second one. This is the one that's kind of similar to U substitution. Okay, so number 6, integration by parts. Just follow along with me, please. And I don't know. I'll have you practice one of these today, and then that'll be it. Okay, so first off, here's the notes, and let's go ahead and fill it in the way they're asking. If you're trying to integrate f times g prime, again, some of this won't make sense for just a minute, but if you're trying to do that, there's a formula that works for integration by parts. Your answer to this integration will be f of x times g of x minus what you get from integrating f prime of x g of x. Now, I will tell you, my brain doesn't work this way. This is a f prime on this one. Make sure you catch that. My brain doesn't work this way. This was not how it was taught to me. Most people learn this as u and v's. If you're integrating u times v prime, I want you to write down both because you might prefer this one. But integrating u v prime, again, this is just a different representation, ends up being u times v minus integrating v u prime. This is the one that I'm going to use. It's a formula that, again, if you can figure out what u is and you can figure out what v is, we can just apply that formula and it does the integration for us. Now, these questions will kind of look like product rule, but keep in mind product rule is derivatives and we're doing integration. But notice this looks like something times something, something times something, integrating something times something, something times something. So if it didn't look like something I had memorized, if it didn't look like U substitution, and it looks like you're integrating something times something, that's how you know it's this question type and not partial fractions. Partial fractions should be a big fraction. Now, to show you where this formula comes from, you can actually use the product rule, and we're going to derive this integration by parts formula. So basically, it just says the derivative of f times g. So if you were doing product rule, this would be the product rule. The derivative of the first times the second left alone plus then the opposite order. So imagine, if you will, if we subtract this part over, subtract this over, and then if I try to integrate both sides, that keeps it equivalent because I'm doing it to both sides. Well, what can I take the derivative of to get fg derivative, fg prime? F and g, or now look right here, f and g, that's where those come from, minus, now when I got to integrate this whole thing, So minus the integration of f prime g do you see how that's where the formula comes from? So you won't have to derive it for me, but if you just take the product rule, move this to the other side, and integrate both sides, you have discovered integration by parts. Okay, let's look at an example of the algebra approach, and then there's also a tabular approach, and I'll do one more example for you on the back and ask you to do one example on the back, and then that's all of this we'll do today. We'll worry about actually getting some more practice under our belt next class. All right, so again, if you prefer keeping up with f and g and f prime and g prime, more power to you. But most people learn it as u and v. So that's how I'm going to do it. The problem with doing f and g, in my opinion, is, you know, one question could throw a h of x in there, and then you're trying to remember h of x is the same as g of x, and then it just gets complicated. Using v shouldn't be an issue. Okay, so for f or u, you should choose something that becomes simpler when you differentiate. So if I want to integrate x sine x dx, which one of these should be u?
X.
Probably x, and we're going to take the derivative of that, which is 1 and a dx. You really kind of want to keep it with that dx. Remember, when we do u substitution, you get du over dx, and you multiply the dx over. I'm just skipping that step. Okay, for v or g prime, whichever you want to call it, it needs to be something that can be easily integrated. And in fact, in my brain, I just always learned this as it was all the other stuff. So if you pick out the correct u, v prime should be the other stuff. Now that's not v, that's v prime. So to go from v prime to v, we need to integrate both sides. Integrate, integrate. What can I take the derivative of to get sine x? Cosine x or negative cosine x? Negative. Be careful with that. Depending on which one you're going, and if you're talking about derivatives or integrals, sometimes it's negative, sometimes it's not. My advice is check by taking the derivative. You should feel more comfortable with the derivative. Okay, well, now we're almost done, because the way this guy integrates fits this formula. It's u v minus integrating v u prime. The last thing to do would be to do this integration. What's the antiderivative of cosine? One more time. Sine or negative sine? Very good, sine. Check by taking the derivative. The derivative of sine is cosine. And then, of course, a plus c. So once you know that formula and you practice identifying u and v prime, you can see there's not much work to it. It fits a nice, neat pattern. Okay, let's go to the back page. I told you I'd do one more of these with you. And this time I'm going to ask a lot of questions here. But let's do this number 1 on the back page for one more example of this. And then we'll do the table, do one example of or I'll pick one of these table ones out for you, and then we can move along. Okay, so for question 1, again, you should not do this right away. You should still try to use your AB stuff. If this matches to something we have memorized, take the easy approach and just tell me what the answer is. If you think it's U substitution is a little more work, but you should be more comfortable with that. This is not U substitution. How do I know this is not partial fractions like the other handout?
It's not like a fraction.
Yeah, it needs to be a fraction where the denominator factors, right? So the fact that this is integrating something times something, it kind of looks like you're doing product rule, but you're integrating, not taking the derivative. That's your hint that this is probably integration by parts. So we're going to have to figure out what u prime, v prime, and v is. And if we can figure out those things, we mostly just slap them in the formula and we're about done. So which one of these two do you think should be x? Which one of the... Sorry, I gave you the answer. How did I know x should be u? Right, u should probably be something that simplifies as you take the derivative. If u is x, u prime is 1 dx. Yeah. Put the dx there too. It'll keep things simpler. Okay, for v prime, it needs to be everything else. So cosine x dx. To go from v prime to v, you're integrating both sides. The thing that I can take the derivative of to get cosine x would be sine x. Everybody okay with that? Okay, now we're the next to last step basically. The formula tells me how to piece these together for the answer of this. So what does the formula tell me? What's the first part of the formula say to do? Okay, take u times v, so that would be x times the sine of x. Okay, what's the next part of the formula tell us?
Subtract the integral of v prime u.
Close. V u prime. So minus integrating v sine x u prime dx. That's why you really want to have this dx here. If you don't put this dx here, you don't know there's a dx there, and that should cause you concern. You can't integrate without a dx or a du or something to define the variable. Okay, I said that was the next to last step, so now we're just about done. Part of the answer is x sine x. The rest of the answer is going to come from integrating sine of x, which would be negative cosine x, and you still need your plus c. So arithmetic's not too hard. You just have to practice it a few times to make sure that you feel comfortable doing it. Okay, I will also warn you, though, that we're not done with the notes here. We need to do 2 more examples together. Sometimes with integration by parts, it's kind of like chain rule. You could do this, and this integral right here could still be something times something, and your only option is to do integration by parts a second time for one question. And then if you do the integrations by parts a second time and the integral is still something times something and you don't have any other way to do it, you might have to do integration by parts a third time. So that starts to become pretty tedious, and so we've got a way around that for you to practice, and we do this in a table method. Did you learn the table method? You need to take those off. You can't have headsets in a class. The no phones, guys, by the way, there's also no smartwatches and no Bluetooth headsets. So if you have wired headphones for your Chromebook, those are okay, but not the other stuff. Did you ever learn this table method to do this? You did? Okay. So this is a different way to do the same thing. So if you really want to do it the same way we did the first couple of examples, go for it. But you're going to have to do integration by parts like 3 times, I think. Maybe 4 times to do this one problem, just because it breaks down some, but the integral left behind still needs integration by parts. So we've also got this table method where if you pick your u slash f of x, you put that over here. And then your v prime or g prime is everything else. What we are going to do is we are going to take the derivative until we get down to 0. So take the derivative once, twice, 1, 2, 3, 4, 5 times. Take the derivative as many times as you have to get down to 0. Over here, we're going to integrate each time. So that to integrate sine, that would be negative cosine. To integrate negative cosine would be negative sine. To integrate negative sine would go back to positive cosine. To integrate cosine would be negative sine, and to integrate sine goes back to negative cosine. Once again, be very careful with the negative signs there. It depends on if you're going from sine to cosine or cosine to sine, and it depends on if you're talking about derivatives or integrals. Okay, now we're going to line these up with arrows. So you're going to take this first term, match it to the second, second to third, third to fourth, fourth to fifth, and fifth to sixth. And then finally, underline this part of the directions. Use the sign convention, which is plus minus repeating. So this is going to be positive, negative, positive, negative, positive. So the answer to this integral is going to be these two, negative x to the fourth cosine x, plus, now these two, negative sine x, 4x cubed, plus these two, positive cosine x times 12x squared, plus these multiplied together, which would be a negative 24x sine x, and then finally this last one. 24 times negative cosine would be negative 24 cosine x. And even then you need to plus c, but that's the answer that you would get. And so this table method of just writing them down and knowing how to connect these is way faster. Now, the problem is the table method doesn't work 100% of the time. So you can't just say, I'm just always going to do the table method. Okay, I'm going to share the answer to two questions I'd like you to do on this first. I'd like you to stick with these two questions until you get those answers right, and then you can move on to the next handout. So, I'd like you to do this question 2 like this, not the table method, and you should end up with this as an answer. 2/3 x, just copy the answer down to the bottom so you know if you did it correctly. Whoops, sorry. So pick out your u, your v prime, plug them in the formula, and make sure you get to that. Now, when you guys are doing the integration, make sure that you're undoing chain rule. Either do u substitution or check your work by taking the derivatives. If you don't end up with this over 3 or this over 9, you're not doing the small integration problems correctly. You're forgetting to undo the chain rule in those. Okay, everybody have that one written down? Okay, so I want you to try that one, make sure you get to that answer, and then number 8. Number 8, I'd like you to do with the table, because this one you'd have to do multiple times. So I'm just going to call it. Do it with the table, and you should end up with this as an answer. Jot the answer down and give it a shot. Everybody got that answer copied down? Okay. So for the rest of class, do those two questions. Make sure your answers are right. If you're not getting those right answers, work with your neighbor. Ask me. Let me help you. You can do more of those if you want to for fun, but I plan on us doing more of those on Wednesday. Once you finish those two questions, you can spend the rest of class on assignment 7. That's more practice with partial fractions. If you don't finish number 7, you can finish number 7 for homework. So obviously the sooner you start on it, And the more focused you stay, then the less homework you stay. What about cities after the value signs? Why do you stop right after the value signs? That's why you need those, just in case you plug in an eight number.
That's what I got.
Yeah, it should be one of those. Switch your schedule.
That's
First place, yeah, this last one is 3.
Did it mess up other stuff?
You get 1.
Well, it was just that I needed. It was only one class. My first period. That's all class they had. So I had to switch this one.
Cause this one's only offered first and fifth, that's why I thought it might have been. First period's a way cooler class. I understand if you listen.
U times U prime. So prime is the prime of your x plus 1. So the time period you get 1 is not plus. There should be a period.
Lagrange?
Yeah. Just undo it. Gotcha.
Are you there?
Some of these are a little melty, you might want to be careful.
Should be a third. Does he do a third? Yeah. Oh, I didn't.
You want blue? Yeah, you go down. You ever seen those videos of the ice cream? So like street vendors, you go to grab the ice cream and then they just keep doing tricks where you can't get it.
Oh, yeah. Thank you. Those are sticky.
Yeah, well, they like melted. I guess they didn't have the AC on in the building last week or something.
No, that's where it comes from 1 divided by 3.
And then you pull out your 1/3 and then you cosine of the because the antiderivative sine.
I'm not sure. It looks a little vintage. It's like the colors and things.
Thank you.
Oh wait, I already did that. Let me do it again.
Yeah.
Then you just like
Yes.
whenever you copy sine of the turn into cosine where you
Yeah.
Okay, can I get a do this? Yeah.
They've been in the refrigerator. Well, the other one's melted. Look, they like, yeah.
Were they outside or in here?
They were in here all weekend.
That's your original.
All of that.
You could either do use of or you can do the interval very carefully. What I mean by that
I
is,
think you have to do it.
what can you take the derivative and make sure you get the cosine?
Because you need to multiply this by because of the
Sign.
or
Okay.
by 2. And then
Right, so we're gonna say sine variable plus sine. But if you're gonna skip the use substitution, you need to check it. The derivative of sine something is cosine something. But you see, because of chain rule, you would multiply by 3. So the
Yeah.
3, like, is that what you're saying? No, 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 take that. I'm saying if I take the derivative of what you wrote down, that's gonna be cosine of this stuff times the derivative of the inside. Because it changes times 3. But you don't have 3 yet.
Okay.
So you need to put it 1/3 out front to balance out the 3.
Right, so the 1/3 would go out.
That's the same thing you would get with the simplification.
Okay.
But if you can balance that in your head, that one step in your head, it's one right. Just always check the derivative of this, if you're considering chain rules, and you.
Do you have to do
Is
this
it,
all
is
again?
it changed this one?
Because that's what they
Times.
It would just be
Yeah, times the derivative.
Oh, it's just
For sure, I can't listen to that.
Yes. You gotta bring wired headphones.
Is that my only leeway out?
Oh, yeah,
That's your only leeway out.
It's like bringing wired headphones.
Well, it's no phones, no smartwatches, no wireless earbuds.
The wired ones.
Because
You can use wired ones. Problem is you can't use wired ones with your phone.
this. And since we have to do it.
They don't let you do wireless earbuds, 'cause how do you change the song? How do you pause the music?
Like, if my headphones have a thing where if you tap it, it's
How do you change the music?
it's like,
Okay, most people would get their phones out.
no, because my playlist is very curated for my taste.
I thought Drake was gonna be arrested by that.
He probably thinks too much money for that. You don't know?
Which questions did we do?
On that one? Number 8 with the table, and number 2 with the. That's those two.
And then try to integrate.
What do you say?
Today, I'd like you to do question 2,
And do you go 8?
this one. You got the right answer that I had. Number 2, and then number 8. Do that one with the table. Then you can worry about this, because this is gonna be your homework if it's not finished. You're gonna check all your answers? Okay. And you can do as much of that as you have time for.
Is there an animal?
You want to use some
This thing.
Yes.
I got my computer at home, so I can't really check that one.
Okay, well then that doesn't help you too much.
Oh, you know, I didn't make it.
I did make those very nice to look at. You can look at mine.
That's way too much work.
Forgot the plus C. Can't maybe use that.
Okay, I'm gonna put these homeworks in real quick, so if y'all have a math question, give me a few minutes.
So I'm not always on the table, but always like a plus.
Yes.
Okay. Minus. You start with positive.
You won't, oh, you, actually, I'm actually just out.
So just keep taking the derivative. If you x minus, so then you're doing x squared dx. Oh wait, no, x squared It's the first one, and then you take positive first, and then you have, and then you multiply x, then just
The link is the only one. Oh, I think it's in fifth. The other one is still in first. But it's it's like the same price. It's like 18. And they're 18. Probably 18. 45.
Man, I can walk 18.
And or you can get a card. No, 49 with a card.
Wait, you didn't pay? I can do that. I don't play like over 10.
No, I'm trying to
Like it's boring.
So wait, so
Oh, that over 7.
we're passes.
And we have to finish it.
We're doing 2A.
Money.
Yeah, that's 6. And then we have to do 7.
Oh, 7.
There's, if A is 0, then you're gonna have to read about it.
Oh, yes, please. Thank you.
Did you say?
It's you.
8 of each.
Got it? Because 0, 3.
0,
Oh,
3,
divided by 1. I subtract. I'll tell you there. Oh, you have that right there. And the next one is 1 plus 1, which is 2. Then you got
Where are they going?
I'm not about to go to
Well, I forgot that there was a trick to the. I was about to do the really long thing.
I don't know.
The table thing. But then,
Oh,
then
yeah,
I
the
looked at
table's
it.
gonna be way faster.
Then I looked at it and I was like, wait, wouldn't this just
Disappear?
or like not disappear, but like become like you just take make this part.
Oh, no.
Could you actually get in there?
And then you can simplify.
I don't know what you're doing here.
Then you look at it
That was
like.
what you did though.
No, but you're showing that it hasn't been integrated yet. Mine's showing it is integrated and I need to evaluate.
What do you mean?
You've got an integration symbol, which implies you've not integrated it.
Yeah.
Mine does not have an integration symbol.
Well, I did an extra step. Okay.
You're okay with what you're doing?
Mostly. Got it.
Okay. Did you finish this homework thing, number 7?
Number 7.
We should really do that first. We're gonna spend more time on this next class.
Okay.
This was just an introduction.
Or
No, like you guys, like, I guess, like,
Wait, do you still have what we're supposed to get for 2? The answer.
oh, shoot.
Oh, nothing, doing it right at all.
Me?
Number 2. Jot the answer down. While you're up. Just jot the answer down on your page
Yeah.
until you get there.
I forgot to do that.
Okay, is anybody still working on this number 2? Need me to come look at your work and try to push you in the right directions? Okay, what about number 8 with the table? Anybody need me to come help you with the table method on number 8?
You put this where you were.
No, I have scored.
Because let me cover this up. If I take the derivative of something, right? So the derivative of the ratio. You're on the right track. The derivative of sine something would be cosine something, right? But because of chain rule, the derivative that's inside is times 3. See how there's not a 3 up here? So you don't want it to create a 3, so you need to squeeze a 1/3 in there.
Oh, wait, which one is that?
That way, when you take the derivative and consider chain rule, it goes to and that, see, if you don't do that, you're not gonna get here's this one here. And this isn't gonna be 1 9, or 2 9.
Yeah, 32 is actually less than that.
You can also once you do substitution, that way you're not trying to guess it in your head. That's what I was saying. You don't memorize that. Well, maybe you shouldn't try to integrate that. Maybe that should be your derivative side. Maybe that should be using happy time. Does that make sense? Like, you're picking these two, so you might think that it's you and you need, well, you might think it's this and you want to integrate that, but it may be this if you just need to do the derivative.
Is it harder than the next?
Where's your tablet?
Just that, his hands up.
How do you get
Is
this?
that easy?
2/3 and 2
I mean, you usually.
Okay, well, you've got these set up.
Well, yeah.
You got a mistake right here. Let me cover this up.
Maybe they're
If I take the derivative of what you have, what's the derivative of sine something? Okay, cosine something is correct. But you see you have to have someone with your work there.
Figure out how far, like, how many
Yours, the derivative of what you have written there would be times 3. And you don't want there to be a 3 there, so you need to squeeze a 1 there.
better if you just like.
Okay.
Or you could do use substitution. Use substitution does that stuff for you, where you don't have to try to guess in your head.
I sometimes forget to do use self.
But if you don't do that, you're gonna miss this.
Yeah.
So,
I forget I could.
well, that's what a lot of people are doing. That's why I have that hub.
Is there a way to simplify this, or is this how it is?
And I guess you could distribute the TCUs. I mean, you could bring this negative up, and then you can condense this with multiplication, I guess.
Oh, like putting these two, like
Yeah.
that divided by that.
Well, if they're separated by addition, you need to multiply. Should end up like that. I'm gonna say one more time just to make sure you catch it. Assignment 7 does have the answers on the bottom of the back page. Now the answers are condensed, but it is good for you to practice that a little bit too. So if you're not getting one right, don't just move on. There's something you're doing wrong that you need to catch. Work with your neighbors or call me over. We obviously can't do partial fractions all year long, so. These are the you have to remember with logarithms, if there's an exponent on something, you're taking the logarithm. Usually you bring it down, but you could bring it up. And the exponent of a half is the same as the square root. That's what the square root is.
Those two multiply in the natural log.
Yeah, okay, so
And this one divides because it's the trap.
so x
So you're almost there.
I didn't know that.
lx times
Do you know? It's probably changing.
And that's,
You do the.
yeah, I just like use
Oh, really?
constant.
Yeah, I just said if you're willing to do the use of work, you don't have to mentally think about balancing that 3 out with a 1/3. It's a lot quicker if you do that in your head, but use of is the thing that does that so you don't have to do that in your head. So you really just got to pick just pick, you know.
Yeah.
You want to be safe, but take a little bit longer, or do you think you can do it in your head and just be extra careful? And that's really just a personal preference.
Oh, is that not the same thing though?
No,
Is that not just
well, I use it as straight. Yeah, clubs. And
Okay, you guys still have close to 30 minutes. So even if you're struggling with these 2 integration by parts, you should have most of your homework done, number 7.
Was it 2 and 8?
Most, if not all of it.
No, wait.
Huh?
Was it question 8 or question?
Yeah, question 8. Do question 8 with the table.
Yeah, that's just 0.
Yeah, it's on the front page. I'm asking you to try one of each.
Oh, that one? This one?
Because that specific question, if you did this method,
You have to do it.
you're going to have to do it multiple times. Because this part is going to be integration by parts the second and the third and the fourth time.
Okay.
So
Yeah.
you don't want to do it that method. You want to do it by the table.
I understand.
How do you do this one?
I have to just do the natural law questions now. But, okay, so you said it's just gonna be
You have to factor it.
X plus
Oh,
1.
wait. Number
Minus
4.
2.
Is, no.
Wait, can you do 5 with
It's
that?
times -1 minus times -3. Yeah, so it's 2/3.
Yeah.
Yeah.
Wait, but then don't you have to do it multiple
Yeah.
times?
I guess I'll look now.
That works though, that's fine.
Okay.
No, but then you have to do the individual number. No.
And you can get
after
one,
This-
I feel like I'm just.
You're right.
I don't even know what I'm gonna do.
We only can get
That's
1/5
such a great
for
way.
number 2.
Okay, that's almost 1/5. Okay, but then how do you do 6 then?
Okay.
Wait, so the derivative of natural log x is 1 over x.
For A, yeah, I got 2/5.
And then what's after
Okay,
that?
the answer says 1/5.
No, what's the derivative of 1 over?
But I was but I like double checked it and I got 2/5.
It's wrong.
Yeah, and then after.
It's not he's wrong. I don't majority.
Yeah,
Did you get 1/3? Wait.
and then it's 4x.
I got like a 2/3. So,
We're supposed to do it till we get down to 0.
Yeah. I mean, you'll.
this is,
No, it's the right side.
You're supposed to integrate the right side.
Oh, yeah, you're
we said
right.
we didn't need to.
That's what I've heard.
We do technically do use some, but that's just.
Oh, maybe.
That's 2.
No.
And so basically, since if you take the derivative, then you divide by, yeah, it's like this. So then you do 1. So,
What is that?
so we just do the rest of 1.
Oh, wait, but on the video, 5 and 12 are basically.
And then add the rest of 1.
So we figure out 6 and 5.
What?
Because I've been membership.
Oh, and 7.
My membership, I was first week, first week.
Oh, yeah.
Yeah, it wasn't $100 for me.
And you get to use the driving range?
Yeah, I get how many goals at the government.
Wait, how far is it?
For government,
Yeah.
Yes.
So you said let or for.
it's just
You said let.
First.
Like x.
minus 49.
Wait.
Yeah, I go to this. I go here. It's kind of expensive.
Wait, are you 83?
Maybe like number.
These guys
Oh, yeah, I'm 17.
I
Yeah. So, okay.
I need to walk.
It's $10 after that. I
Okay.
will walk for free.
But you can walk for
So
free.
G prime is equal to dx.
Okay.
All of
And
it.
G, like,
I
Nice.
did college
It could
$8.
equal any constant.
Okay, yeah, I'll definitely do
But
that.
it's equal to
That's 5 times cost.
Yeah, yeah,
that doesn't matter.
I didn't know about that.
Jump.
Yeah.
John Mays? Yeah, yeah.
Jump.
Wait, it's f prime times
And
gx.
maybe you get be good at driving engineer.
Oh, wait. No, you don't add the derivative.
Oh, where?
You don't have to.
Oh, okay.
I don't know if I was.
Well, no, but like when you do the derivative of natural log x, it's not 1 over x dx. It's
Yeah,
just
it's
like.
expensive. No, but like without it.
But like, it's.
Well, maybe, no, but, I think the reason why you keep
Uh-huh.
doing this is because for,
Yeah, that's crazy.
no, okay, well,
It's just natural language. But it's natural language design.
When you turn 18. Okay.
But
yeah.
Oh, right.
And so you could get it, like, you could renew it like February 20th.
Is that what we were doing for the partial fraction?
Yeah, it's literally 0.
Oh, no, we were integrating. Oh, I see what you asked for.
Wait, one of the
Yeah, yeah, you do that.
Can you grab? Did it make you grab? Yeah.
Well, you can play nice.
No, you
No, you can't.
Last thing, you have to.
It just presses flat line. No, it's not zero. It's like, it's not zero.
I saw this one.
Oh, no, do zero to us.
Oh.
How much is the contract?
It's like, well, to Kenyon, it's, well, they're on like a wait list right now, but into, yeah, I mean, it's actually, it's pretty eggs.
It's like a
Yeah, it's like, it's like,
It's not one trip. Versus this. One
oh, yeah, Paradise.
Okay, so what is
Yeah, they haven't driving it, so, you might have to be in the room.
That's actually
What do you choose? Or no, like, what's your score?
You raise the stuff.
I don't
Yeah.
know that.
So B squared root of x.
I need to.
That's good because
I usually on Instagram.
Yeah, I'm pretty screaming. On Friday, I
which
played-
means
I got.
you might
I
need to
would've
switch
put it
those
over.
two. This might be the real, that might be the different.
Okay, let's see.
We don't have any, if you know that you're stuck with that way, you might should try another
I
way.
had like 3 OG.
Yes.
One I'm taking by myself, I just, I don't know.
Man.
I would say, I probably should like 10. Probably do 10 over.
Something around.
Probably like 7.
Huh?
Probably like 7.
7 hours? Nope. I don't know if these, I can just like tell you.
So, okay.
I think it's like
Hold on.
4 minutes.
It's fine to me so far.
170.
Yeah.
So this is close to zero.
That's it.
Okay.
Like, for whole.
We're not going to this
So we drive G6, we're doing the fairly.
Straight.
G7.
Okay, I'm gonna look at my work.
Well, I usually like a 3 wood and then I use my hybrid.
Just a second. I need to finish answering their question.
You need to drive it?
Well, I can't like put it there. I just like did 3 wood straight into the fairway. I'm not, well, because I can't like curve around. You know what I'm talking about?
Yeah, yeah.
Because it curves around.
Yeah, it's hard to go back.
Yeah.
But like,
I need to try it though. I've kind of fixed my slides.
you can have a, even, so you know, like, you have stronger.
Yeah.
Weaker, I think stronger gives you like slide.
Oh, you think so?
And then
I think I know what
gives you. Yeah.
Okay, so we should integrate what is on the
Like, yeah. As it, I think you can get it straight.
No, I'm saying the integration by
Yeah.
parts. Ask you to integrate what
It's just,
comes
it's a
where.
tough angle. Yeah,
Where you integrated this from?
What is that?
E prime is one, the E can't be one. The derivative of one is not one.
The, where you go up that hill.
If you times the x here.
I usually shoot good on, you know the par 3?
Yeah, okay, that's
Oh,
did you get?
That's
That's
like
like
that.
that. Yeah, yeah, sorry. Okay, that's fine.
So it's not the one you shoot,
Right. So you're these zero,
like
yeah.
minus one
So
half.
that's all minus x.
After the.
Okay, that makes so much more sense.
Yeah.
Okay. So
Because
it was x elements minus that first.
But I wasn't able to get the one with the 5%.
Oh, I hate that. That's my least favorite.
Yeah, 2 bits.
It says if you drive and you don't
So it's just equal to
I'm
x
always
ln x
just
minus.
I might have done something.
Yeah.
That's not really an actual log.
No, because that time that x equals
It would be like minus 5 halves. And this one is
So just the
minus
x
1.
ln x
I
minus.
swear.
So
That's
it'd
the
be
worst
like
goal.
minus 1 times
I don't know, maybe.
negative 2 fifths.
Okay, it doesn't matter.
I think so.
So how do you
2 fifths.
I think they can.
Oh yeah.
Probably sign now.
No, but it's still.
Okay, right here, we're taking negative 1/2.
Wait, no.
This goes to
You're not-
0.
What are they gonna do?
This would be
But
8
now
times negative 2.5.
Yeah, negative 5 halves.
Negative 5.5. Okay.
I always hit my driver.
Okay. What about the other side?
That would just be negative 1.
Yeah. Oh.
Negative 1?
Oh, I guess.
Yeah.
So A is 2 fifths. Okay, that sounds right.
But it says 1/5 in it.
I would.
Okay, I'm gonna I have these online, but I don't have the hard copy.
No, you don't do that.
Like, I got like the natural log and absolute value stuff right, but it's just the 1/5 I don't have for the constant.
I could like, good.
It's like if I want to do straight, but like 270, 250, not like
250 is pretty.
300.
Yeah, but like,
Definitely not.
the links is so easy.
Movies, the wait like an hour.
Yeah,
Yeah, movies when I saw it, we had to wait for an hour. There was like a very good golf team that, yeah.
There was a group, one of us, was 2 guys, 4 girls, with 2 cars, 3 cars. 2 of them were walking, 4 of them were driving.
That doesn't make sense. Were they out of cars or something?
No, we just didn't get it, I don't know why. That's weird. Anyway.
So you can walk for free, that's good.
Yeah.
I'm actually gonna get that.
I pay at least.
Okay. I don't know.
Yeah.
I'm gonna have to, let me work it from scratch. Cause just glancing at your work, I'm making sense.
Saturday and Sunday. And like I'll pay 3 times a week. You kind of have to pay.
Yeah, it's pretty.
Oh, now.
How do you do that?
That's too much.
What you get? After you get the head of the June?
Oh, you just plug it in.
Diego, did you put A over 2x plus 1 or x minus 2?
It was a sport.
I put it over 2x plus 1.
What do you get?
I just want to set it up the same way as you.
Do you ever pay parking?
I was talking about like,
Minus X.
what's it called?
Lakeside?
Yeah, Lakeside, that's
Oh
it.
my god, this one number 25x.
I played it like
Oh,
3
yeah.
years ago when I'd never gone before.
That's
Guys, y'all are done? I'm guessing that's a no.
You have to do it 4 times. And I'm pretty sure
feel like it calls for. Because then you're gonna, because inside the inner core you get left with like you don't have to do it whenever whenever your third is a constant.
I think I saw it cleared it out.
Did I make an issue?
Oh. No, but not necessarily because in this question, because it cancels, right?
Did I do something wrong?
It's right here.
I tried it.
You don't just get natural like that. Natural like this times the version of 2. You don't want the 2 to be there, so you need to divide that by 2. So that's the same. Your substitution always works, otherwise you just need to be careful. Anytime you integrate, take the derivative of what you got and make sure it relates to that. So physically change that.
I'll keep that in mind.
No, but like mine's wrong.
Because it's minus 125. And then it's just not
And the 1 is super 1 minus 1.
Too easy?
Come on, where's the challenge?
Anything on the Okay.
Oh, no.
Yeah, it was 2. So we got A for
That's correct.
the answer is this. 1 over 5.
Yeah, the answer is. Your A was correct, so right here, here. How do you integrate 1 over 2x plus 1?
Is there a chain rule?
Yeah, so you get natural log of 2x plus 1, but test this, you either have to do U substitution or you have to test your derivative. The derivative of natural log of 2x plus 1 would be 1 over 2x plus 1, but times 2 because of chain rule. So you need to divide this by 2 to balance it out. It does, it multiplies by 2, but you don't want it to be there. So you need to multiply it by 1/2 to make it balance out. Or you can just do your substitution and you don't have to do that in your head. It's more work, but it will always work.
No, I just got a wrong answer. Yeah. Wait.
Yeah, this is one that's
Oh, so we're wrong. But it doesn't explain the subtraction. Oh. Yeah, we completely forgot about this.
And then you would use x, that's equal to x and you would
Oh, okay. Yeah, I caught it on fire.
Okay, that's something that we have to put later.
Good, that's the point. Learn from your mistakes.
Yeah.
Nobody does all this stuff right their first try.
2. You did?
No,
Oh, no, then it would go back to, I thought like,
Don't have problems with this, like, rubbing your hands.
Yeah, that's why I always take it off. Everybody, it spreads out everywhere.
Somebody said if you put some fabric tape here or something.
Shifts, and then and then there's like all these different commands. You have to flip it around, and then it says last and goes to the name, and if you do a long thing, then and then they don't get
How have y'all been doing? You've been harder than
I'm not here much anyway, so it's fine.
I got 3 classes now.
Oh, good. How do you get your homework?
Oh yeah, no, that'll be stable.
Are you doing set?
And I got comp 2, but I'm at a comp 1.
No,
so
that-
I'm here for this semester.
It's only one stuff. If you make use of all of that,
So you have a job then?
you probably make
Okay,
more.
where do you work?
And then tomorrow they
Taco and Tyler.
yeah, but it's like behind.
Where's that at?
How do you know?
It's right here by, it's in like right as you come down the hill. It's like by Central Barbecue. Those two are right by each other.
You could do that thing.
They opened up, I think, like, it was like a year ago.
Oh shoot, we did it good.
Okay,
I like it.
Without the,
Is that why you work there?
Partially. They pay good too, though.
oh,
Yeah, I think we got it.
I would never.
Thank you.
No other ideas, so.
Neither do I.
I'm gonna say, you give me a hard time in class, I'll go to your work and give you a hard time. But we did have a teacher do that a few years ago. Except it was at a school basketball game. He like went and heckled the students. Well, because the student was being a jerk in class all the time. So he wanted to show them what it was like. Well, the teacher got fired. Not the best idea. I get his, what he was trying to do, but it's probably not the best way to go about it.
Every 4 weeks, we have to write up or write come down. And so we're constantly.
It's 40, I think it's like server harder. There's always one.
Yeah, 'cause always check the derivative or just do such
We have to do like round and round, and then back and forth, which is
or just like oh shoot.
you know, something
Well, we are doing somersaults and stuff.
like backhand swing.
Oh shoot.
Yeah.
Yeah.
Super simple.
Cherry and grape are always the hardest to eat. Just the flavor of medicine when I grew up.
Yeah, that's
Was that medicine, not cherry and grape?
so it's like realistic stuff like that.
The flavor?
No flavor one.
Oh, no flavor.
Sometimes I make this one, and sometimes we lift.
I thought medicine was supposed to kind of taste bad though, as a kid, so I'm just
Go
drinking
down
a
the
bottle.
flavor and refrigerate.
Oh,
Flavorless, you don't know you're doing it.
oh no, art.
Yeah. You use the Did you guys?
Are we usually using trials today?
Yeah, we today.
It's just today or something.
I bought the Germex around the room.
No, it's like a couple minutes. I don't know what he's up to, but it's really big.
It's not even legal, it's like 90 degrees.
Well, half of us are going to the weight room, so hopefully.
You're out. 10
When we chose to get this,
Okay, 3 things. We got about 5 minutes left. So first up, you need to make sure you know what your homework is. If you did not finish number 7, I need you to try all of those. Check with the answers on the back page before class on Wednesday. That's number 1. Number 2, can somebody explain the daily meme to us?
Well,
Yeah.
the 8 is on the top one, and if you plug in the infinity with the limit, it's
Yeah.
just infinity over infinity, which is just infinity.
Okay.
And it looks like the 8, but and then you do the same thing on the bottom. It's also infinity, but with but because the infinity looks like a sideways 8, then like the 5, like the sideways 5.
All right. Somebody thought the answer to the first one was sideways 8, so the second one must be sideways 5.
None of those
three people are mathematicians.
Einstein?
Well, he's a physicist.
Well, like that's.
I can't be
not-
both?
No.
I think physics has
It's different. Like one of the Newton or something.
Okay.
Like
Where do you find these? Like Reddit?
Memes?
Yeah.
Google?
I've missed them.
You say math memes in Google, go to the image tab and there's thousands.
I missed
It's just some of them are not school appropriate.
Okay.
I'm glad I'm back.
Alright, and then here's another optional puzzle. This one's might be the easiest one yet.
Oh crowd. Okay.
Feeling nervous. Got my first shift of work after this period.
First job? First job?
Where's my calculator? Where are the calculators?
I'm just kind of nervous because I've never done something like this before.
Just be a hard worker and a good listener and try to learn fast.
Yeah.
Ask questions when you don't know something important. Over time you'll be fine.
Yeah. I just thought I kind of want to pay for myself for a lot of things because I've been mooching off a lot of people. And I haven't had a lot of pocket money, so I'm just thinking, why not start right now? I've got like 2 real classes in band.
I'm up in the difficulty.
Yeah, that's for the attention. Well, you don't have the time to do it. No, so we did one time, so let's make it white, it's 1 half first, right, and then you make a white sauce, and it's 11 or 23 after. But then we only the white, we multiply by 2, because there's a white in the black sauce. So we 2 times 1
Everybody have an answer?
11 over 23.
What percentage is that? Higher or lower than 50?
Lower.
How do you know that?
Is this non
42.
Oh, I get it. Okay. I think I understand.
You're right. My first period complained that this wasn't a puzzle and it was more of a math question.
I got 44%.
I don't think that one's
It's like 48%.
Oh, it is.
It's 11 23rds.
Yeah, I could figure that out. Yeah.
As I've been doing, I put it in Google Classroom if you want an explanation on how to figure it out. Have a good day.